very first pictures are emerging from India's rover on Earth's satellite. The Chandrayaan-3 rover has captured the moon's image just prior to touchdown.
We all celebrated when Chandrayaan-3 touched down on the moon's uncharted south pole. But as the dust settled, a shadow of uncertainty began to surface. The data quite didn't add up. There were strange heat signatures, sulfur deposits in odd places, and rumors of visuals that were never supposed to be seen. Is this just lunar science at its finest, or could there be more to the moon than we ever imagined? Let's find out. Iki. Of course, every mystery has a starting point. And in this case, it begins with Chandrayaan-3's journey to a part of the moon no one had ever reached before. Now, before we get lost in all the theories and speculations, let's rewind for a moment and look at how Chandrayaan-3 made history. Reaching the unreachable, Chandrayaan-3's historic landing. India's journey to the moon didn't start with Chandrayaan-3. It began years earlier with a small spacecraft that made a very big discovery. In 2008, Chandrayaan-1 was created. It was India's first deep space mission. Chandrayaan-1 flew to the moon and found something no one had confirmed before. What was found wasn't puddles or lakes, but tiny traces of water molecules trapped in the lunar soil. This single mission put India on the global map of space exploration. It was a quiet success that changed how we look at the moon. That achievement laid the foundation for what came next. In 2019, India set its sights
Its Chandrayaan-2 lunar mission on Saturday, an unmanned probe near the south pole of the moon.
even higher with Chandrayaan-2, this time aiming to land a rover on the moon's south pole. Everything was going well until the lander, Vikram, lost control in the final moments and crashed. It was heartbreaking, but not the end. The failure taught the Indian Space Research Organisation, ISRO, what needed fixing. So instead of giving up, they got back to work. Now, this is how the idea of Chandrayaan-3 emerged. Not as a fresh start, but as a continuation of a mission they didn't want to abandon. Launched on July 14, 2023, this mission had one goal. It was basically designed to make it to the moon's south pole and land safely. And on August 23, 2023, that's exactly what happened. For the first time in history, a spacecraft touched down near the moon's south pole and stayed in one piece. India became the fourth country to ever land on the moon and the first to do it in that region, a region no one else had even dared to try. However, you might wonder, why all this fuss about the South Pole? Well, scientists believe this area holds secrets that could change the future of space exploration. Because of how the sunlight hits the moon, some craters near the South Pole are always in shadow. These places are so cold, they might have trapped ice for billions of years. If that ice is real, it could be used for drinking water, oxygen, even fuel for rockets. That's why landing here is not just about being first, it's about opening doors for future missions, including human settlements one day. When the news broke that Chandrayaan-3 had landed, the reaction was electric. Across India, people celebrated in homes, schools, and city streets. Inside Mission Control, you could see tears, cheers, and pure relief. Prime Minister Modi joined the broadcast, proudly saying, "India is on the moon! We have our national pride placed on the moon." The world took notice. It wasn't just India's victory. It was a reminder that space isn't owned by a few powerful nations, and anyone with vision and hard work can get there. With the landing complete, it was time for the real mission to begin, one that would unfold slowly, but with surprises no one had expected. A lander and a rover. As we all know, when Chandrayaan-3 landed on the moon, the world celebrated. But for the team at ISRO, the real work was just beginning. The landing was only the opening act. After landing, it was up to two small machines to quietly search for clues in a place no one had ever explored up close.
India has the Vikram lander and the Pragyan rover on Chandrayaan-3.
These machines were called Vikram, the lander, and Pragyan, the rover. First, let's talk about Vikram. Vikram was the anchor of the mission. It was designed to land safely and serve as a science station, packed with instruments ready to study the moon's surface and the space above it. One of its main tools was called uncharted. This device wasn't designed to look impressive, but it knew how to get the job done. It gently pushed a probe into the lunar soil and measured how heat moved through the ground, inch by inch. This helped scientists understand how the moon's surface handles temperature changes, something that's very different at the South Pole. Another instrument on Vikram was ILSA, a device that listened for moonquakes. The South Pole had never been monitored for seismic activity before. Any tremor, no matter how small, could reveal new clues about what's happening beneath the surface. Vikram also carried a Langmuir probe, a tool that measured the thin layer of charged particles floating just above the moon's surface. It's a strange environment out there, and this probe helped scientists see how the plasma behaves when sunlight hits the lunar ground. But that was only half the story. Pragyan, the rover, was built to go beyond, exploring the surface up close. If Vikram was the base of operations, then Pragyan was the one venturing out, checking what lay beyond. Once it rolled down the ramp, it began scanning the surface with two key instruments. One was APXS, which analyzed the soil's chemical makeup by firing alpha particles and X-rays at it. The other was LIBS, a laser that zapped the soil and studied the tiny plasma bursts that came from the impact. Through this, Pragyan could detect elements like sulfur, aluminum, and iron. This combination of lander and rover was not new. Chandrayaan-3 had a similar setup, but that mission didn't go as planned. The lander lost control during its final descent and crashed. It was a tough moment for ISRO, but they didn't walk away from the challenge. They studied every detail of what went wrong and came back stronger. For Chandrayaan-3, they upgraded Vikram's sensors, tweaked the landing algorithms, and even removed an engine to make the descent more stable.
The Chandrayaan-2 will be used even during Chandrayaan-3.
Every mistake from Chandrayaan-2 became a lesson for Chandrayaan-3. This time the landing was flawless, but what happened next caught everyone off guard. As part of a follow-up test, ISRO instructed Vikram to perform a gentle hop, lifting itself off the surface and landing a few meters away. This was a crucial experiment to see how it would handle liftoff in lunar conditions. During a maneuver, the lander lifted off the lunar surface and shifted itself about 40 centimeters to the side. It was a small move, barely a nudge in space terms, but it meant something big. Vikram had just proven that controlled takeoff and landing on the moon was possible, and that tiny hop opened up ideas for future lunar mobility that no one had thought of before. Together, Vikram and Pragyan started uncovering data that had never been recorded from the moon's south pole. Chasti provided detailed readings on how the temperature shifted as sunlight touched the ground, revealing that heat doesn't spread the same way across different patches of soil. ILSA caught seismic signals, sparking questions about whether these were caused by micrometeorites or if the ground itself was shifting. The Langmuir probe showed how the plasma environment changed from day to night. Meanwhile, Pragyan was busy analyzing the lunar soil. When it detected sulfur in the surface materials, it marked the first time sulfur had been confirmed on site at the South Pole. These readings were important because they told scientists more about the moon's volcanic past and how elements got distributed across its surface. This wasn't one of those big, showy space missions. It was basically just two machines sent to quietly explore somewhere we've never been. Every move they made was slow, deliberate, and packed with purpose. What made it even more fascinating was how some of the data didn't line up with what scientists expected. Certain readings raised more questions than answers, and that's when the excitement really began to build. Because when you send a mission to a place no one has been, you can't always predict what you'll find. But in this case, Vikram and Pragyan might have stumbled onto something that could change the way we see the moon forever. Now, while the mission seemed to be going exactly as planned, some of the data coming back began to suggest there was more to this region than anyone had expected. Strange discoveries at the edge of darkness. The first few days on the moon felt like clockwork. Vikram and Pragyan were ticking off tasks one by one, feeding back data that looked exactly how the scientists expected. Apparently, everything was too smooth. That's why no one was prepared for what happened next. The first curveball came from the soil itself. When Pragyan started zapping the ground with its laser,
near the south pole of the moon.
it picked up something no one had ever confirmed at the moon's south pole: sulfur. You'd think it would be a minor detail, but to lunar scientists, sulfur isn't just any element. Its presence could mean ancient volcanic eruptions left traces in the soil, or perhaps meteorites delivered it over billions of years. Either way, finding it where no one had looked before was a big deal, but that wasn't the only surprise. The thermal readings started behaving oddly. Vikram's CHAST probe was designed to measure how temperatures change as it digs into the lunar surface. What it found didn't match what anyone had predicted. At the very top, where sunlight hits, the surface was heating up to a scorching 82 degrees Celsius, which is far hotter than what ISRO scientists had predicted, and much higher than the 57 degrees Celsius they expected. But just a few centimeters below that, temperatures were plunging below freezing. In fact, they dropped to around minus 10 degrees or even lower. On the surface, it seems simple, but there's more to it. The thing is, the moon doesn't have an atmosphere to spread heat around, so the surface can get scorching hot, while just a few inches below stays freezing cold. This extreme temperature swing was way bigger than scientists expected. This isn't just a random fact for trivia night. It has real implications. For future moon bases, this temperature layer could act as a natural insulator. It might be the key to designing habitats that can survive the moon's harsh day-night cycles. As if that wasn't enough, the rover's spectrometers added more to the story. Besides sulfur, they detected a cocktail of metals like aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. These are the building blocks of the moon's surface, but seeing them mapped out in such detail gave scientists new insights into how this region was formed. It painted a picture of ancient impacts, lava flows, and a surface that has been through billions of years of cosmic weathering. Yet, the plasma mystery was still waiting to be uncovered. Vikram's Langmuir probe measured how the thin layer of plasma, or charged particles floating just above the lunar surface, changed throughout the day. It seems like the readings didn't stay consistent. As the sunlight moved, plasma densities rose and fell in ways that models hadn't predicted. This isn't the typical atmosphere. It's an exosphere, fragile and thin. Yet it was behaving dynamically, reacting to the sun in a pattern that no one had fully understood until now. One by one, these findings began to build a narrative that was far more complicated than anyone had imagined. The moon's south pole wasn't a frozen wasteland of silence. It was alive with subtle shifts like heat gradients, chemical clues, electric activity in the plasma. Every reading and every number hinted at a surface that had been shaped by forces still not fully understood. And while none of these discoveries screamed out a headline-grabbing mystery, they whispered something very more intriguing. The moon was hiding layers of stories beneath its dust, stories that weren't obvious until someone landed right there and took a closer look. This is why Chandrayaan-3’s data started turning heads. The mission focused on patience and precision, turning odd readings into a clearer picture of what the moon's ancient past looked like. And those strange readings began to suggest that the South Pole had much more to tell. All these discoveries are exciting, but they're pieces of a much larger puzzle that began billions of years ago, when the moon's surface wasn't even solid yet. The magma ocean theory and the moon's evolving story. When Chandrayaan-3 started sending back data, most people were focused on the surface, like what the soil looked like and what minerals were there. But as the readings rolled in, something interesting began to stand out. The area where Vikram and Pragyan landed wasn't giving a variety of compositions like many had expected. Instead, the soil samples showed a strikingly uniform mix of minerals. No matter where the rover moved, the numbers stayed almost identical. To scientists, that kind of consistency wasn't random. It pointed to something much bigger, which was the moon's fiery past. You see, billions of years ago, after a massive collision between Earth and a Mars-sized object, the moon was born. But it didn't cool off immediately. In fact, its entire surface turned into a molten ocean of magma. As time passed, the surface began to solidify. The lighter minerals floated upward to form a crust, while the heavier ones sank deep into the interior. Chandrayaan-3’s findings added more weight to that theory. The uniformity of the surface composition matched the kind of crust you'd expect if it had once floated on a vast magma ocean. It was like looking at a frozen snapshot from the moon's earliest days. But the story didn't end there. Among the familiar elements, the rover detected something that made researchers take a closer look, and that was magnesium. Its presence hinted at materials that shouldn't have been on the surface in such abundance. Scientists believe these magnesium-rich fragments came from deep within the moon's mantle, thrown across the region by a colossal impact from a nearby crater known as the South Pole Aitken Basin. This crater is one of the largest and oldest impact scars in the solar system, and its debris scattered far and wide, possibly reaching where Chandrayaan-3 landed. However, this discovery raises more questions. Is the moon's crust as simple as a cooled magma shell, or is it layered with materials from ancient collisions and internal shifts we're only beginning to understand? And could these blended layers be telling us a more complicated story about the moon's evolution? Another intriguing aspect involves the shadowed craters near the poles. These regions are so cold and untouched by sunlight that they might be holding ancient water ice, not bodies of water per se, but tiny grains trapped in the regolith. Could this ice carry chemical clues to the moon's early environment? Or, more boldly, could it preserve organic signatures that hints of ancient cosmic material that once drifted through our solar system? Then there's this question that keeps coming back. Is the moon really dead? We often think of it as a static, lifeless rock, but if impacts have churned up deeper materials, and if thermal anomalies exist beneath its surface, is it possible that some pockets of molten rock still linger in the depths? While active volcanism hasn't been observed in modern times, the ingredients that created those ancient flows might not be completely gone. Chandrayaan-3's data didn't claim to have found hidden lava chambers or underground reservoirs. What it did, however, was reignite curiosity. The moon's surface is a record of intense heat, violent impacts, and frozen time. Yet, every new measurement, from magnesium traces to temperature shifts, suggests there are still layers of its story waiting to be uncovered. And now, knowing what we've uncovered, it's fair to wonder, is the moon's story fully written? Or is our satellite still holding chapters we haven't quite learned yet? Everything so far had a scientific explanation, until they found something underground that made everyone pause. The real question now was simple. What else is hiding in the shadows, waiting to be found? A hint of lunar engineering. While most of the world was focused on Chandrayaan-3's surface moves, the real intrigue was happening beneath the moon's skin. As ISRO's team pored over the data, something unusual started to pop up. It was something that didn't look like part of the usual lunar landscape. It turns out that Vikram and Pragyan had touched down in the middle of a big, ancient crater. Not the kind you can see with a telescope, though. This one was buried and hidden under layers of dust and rock, stretching nearly 160 kilometers wide. It's one of the oldest known impact scars on the moon, yet completely invisible to the naked eye. You wouldn't know it was there, even if you were standing on it. This discovery wasn't random. It came from careful analysis of surface scans, images from Chandrayaan-2's orbiter, and subtle geomagnetic shifts picked up by the instruments. What made this crater special wasn't its size. Well, craters that big aren't rare on the moon. But what made it special was how perfectly preserved it seemed beneath the layers. It was almost like time had forgotten to erase it completely. And here's where things get interesting. Some researchers believe these kinds of buried structures could be cosmic leftovers, from when the moon's surface was a chaotic mess of lava flows, meteorite impacts, and shifting crusts. Others aren't so sure. Ground-penetrating scans have picked up low-density zones that appear oddly geometric, and voids under the surface don't entirely look natural. Could these be collapsed lava tubes? Or are they something else entirely? Of course, theories started floating around, but then could these underground shapes be evidence of ancient lunar engineering? It's a wild thought, but space exploration has always danced between facts and what-ifs. Whether it's architecture carved by intelligent hands or simply nature's strange designs, the idea is tempting. So, What would you think if we discovered an underground structure on the moon, something that looks oddly architectural? Would you see it as an evolutionary accident of geology, or something more intriguing? If Pragyan had discovered an underground moon base, would it change how you think about life beyond Earth? We're in the territory where science meets possibility and a buried void that doesn't offer answers yet, only puzzles. However, at the edge of what we know, curiosity takes over. Let me know your thoughts in the comments below. Don't forget to like, share and subscribe to our channel so you never miss any of our uploads. To enjoy more content like this, click on the next video on your screen.